y-axis, and the function y squared equals 9 minus x. So we've got this kind of curved shape because it's a y squared term. It's not technically one of the function that we would normally use, because for any value of x, there's two values of y. So but it's an interesting one because we can still work out the area, in this case, between the curve and the y-axis. So there's a couple of things we've got to remember. So first of all, the area that we might be looking for has to be the area of f of y dy. So we need to make sure that we've got our function in terms of y. Now that means y on the right hand side. So if we've got y squared equals 9 minus x, then we could say that effectively we want to x equals, so we could say that if you add x to both sides, x plus 9, y squared equals 9, x equals 9 minus y squared. What we then want to do, so we've got area is the integral of 9 minus y squared dy. We have to work out our upper and lower bounds here, these 2 points here. In other words, the y-intercepts of the function. So we want to find our limits, which, in other words, y-intercepts when x equals 0. Always good to remember that y-intercepts occur when the x value is 0, x-intercepts occur when y equals 0. So going back to the original expression, y squared equals 9 minus x. If we want x to be equal 0, we can just say that y squared therefore equals 9. Y is plus or minus the square root of 9, which is plus or minus 3. In other words, our two intercept points are negative 3 and 3, which means that's our limits here on the integration. So we can go ahead and do integration in terms of y. So 9 integrates to 9y, and negative y squared integrates to negative y cubed over 3. And we've got 3 at the top and negative 3 on the bottom. And it's just a matter of substituting that in. So that gives us 9 times 3 minus 3 cubed divided by 3 minus, and we're doing the same thing for negative 3. So just watch that. I'm just going to put that straight in as negative 27 minus negative 3 cubed over 3, which becomes 27. 3 cubed divided by 3 is 9. And multiplying out that bracket, I've got plus 27 there. Negative 3 cubed is negative 27 divided by 3 is negative 9. Multiplied by negative 1 is plus 9. So there's lots of ways in which you can actually make a mistake. I'm just going to double check that. Negative, yep, except that, yeah, okay, there's too many negatives going on here. So let's keep that just in the bracket there. That becomes plus 9. I was just trying to multiply it at the same time. So 27 take away 9 is 18. Subtract negative 27, add 9 is negative 18. So that gives us 36. Okay, what is 36? 36 is the area. So let's just rewrite that. Area is equal to 36 square units. Sometimes it's good just to dial back. Don't do too much in one go. Otherwise, you'll start making mistakes. So there's the area. Notice that in previous calculus, you might have had an alarm bell going on when we have areas above and below the x-axis, and you go, oh, that we can't do that because one's going to be positive, one's going to be negative. Well, the whole point about this is you can do it with this, is because everything's switched to The y-axis, if you think about it, where's our origin? That's the origin here. With the y-axis, these are all positive, and it's to the left of the y-axis it would be negative. So you would have to take care if you were trying to find the area of a shape which included parts to the left of the y-axis, you would have to kind of split it up in the same way. But we're not going to really look at that at the moment. This is new enough that we're going to not have to worry about negative areas on when we're looking at areas between a curve and the y-axis. Just thought I would throw that point in though. Okay, there's example 16. You can go off and have a go at some problems involving area and the y-axis.